So compute the monthly returns. So I'll show you how to do that. Once you've done this, the rest is mechanical. You drag and drop. Yeah, computing monthly returns is not that difficult. Average returns, mechanical. We'll do that. Compute the variance-covariance matrix. 4 of these returns. Now you start here, guys. This is the key point here. This is loop. You come back to number 4, 5, 6 in point 7. This is a repetitive process now. For the first case, you start pick 2 companies, then compute the expected return, standard deviation, and portfolio beta for the minimum variance portfolio. Now, this part is just part that I showed on the video as well, calculating the portfolio variance and standard deviation. With 2 stocks, 3 stocks, 4 stocks, the same procedure. It's just number of stocks increase. Nothing changed. Now, you have to find minimum variance portfolio using solver. So this is, obviously everyone knows it. Is everyone aware of that? Yes?
Yeah, I'm aware, but can you do it again? Because I watched the video and I'm not very sure.
I'll do that. Don't worry. I need to just go through this guide because it seems like students are not using this guide in the right way. So then, do not assume short sale of the asset is not allowed. That implies you have to create a condition in solver making sure that there is no negative allocation. There could be possibly a negative allocation as well, which I'll show you. When I show you, it will become clear. For now, let's assume there is no short sale. Short sale means you actually don't buy the stock, you actually borrow the stock, right? Then in the portfolio weights, you get a negative value. That negative value implies a short sale of the stock. That's technical term, but we will see. And you repeat these steps, including more stocks each time, 3, 4, 5, up to 30 stocks. But you just a loop, goes on and on. Then this part.
Sorry, I don't get the part where you repeat this thing.
This one.
Yes.
So once you finish with once you finish calculating the standard deviation and mean of the portfolio with 2 stocks, you add the 3rd stock and repeat part 5, point 5.
Then we add another
6,
one
7, 8,
But
9,
then we have
10.
to write for every company that we add the mean, the average return.
They are there, aren't they? You calculate them.
Yeah, but do we have to say with company 1 and 2 we get this, with company 1, 2, and 3 we get this?
No, you don't write them. You put them on a curve to see if the total risk declined.
Like, if we add the first and the second one, it will be one thing, and if we add the first and the last one, it will be a different thing. So
What I'm saying is, I'll show you in a minute. I think this is where the confusion comes from.
Yeah.
You pick the first 2, you add sequentially the remaining. You don't remove anything from the portfolio. You keep adding.
I'm not saying we're going to remove anything. I'm saying that if it's the first 2 in the Excel, and if it's the first and the last, like the last one is different. So
That's fine. I mean, if you pick the 2,
that's okay.
then pick the in between them, anything, one by one, yeah.
They could be random.
Yeah. You have to pick random 2, yeah. You first make the random 2 choice, and then one by one add remaining. One by one. So you will have a portfolio of 29, basically 29 portfolios. Yeah, out of 30 stocks, you have 29 portfolios, yeah? Because you start with 2 stocks, not 1, as a portfolio. So you have now 29 different standard deviations which come on the y-axis. And on the x-axis, you have numbers showing the portfolio size. And you draw the total risk and see if the total risk really declined exponentially as the theory says. So it's the test of the theory that you're doing, basically. Portfolio analysis theory. So we will do that in a minute. Now, once you finish that, so there are other things to look at, but we'll probably come back to it later now. And then there's the part 8, which is the second part. You have to create this efficient set using 2 portfolios, which I will, again, provide further videos on this. Okay? This last part is the easiest. The difficult part here in the last part is theory part. You just need to explain what efficient set, whether they...
That's the easiest part.
You think easy? That's good. It's just writing part. Takes time.
Yeah,
Calculation?
it takes time, but it's easier than this.
Than this?
This confusing.
Now I see where the confusion. Okay, thank you. Right, let's go and do. This is what I downloaded previously. This is date. Sorry. I'll have to change them to date now. Not time, date. Long date. Okay. Short date. Yeah. The usual thing. Yeah, you download one by one. Now, this is FTSE 100, the market return. And these are stocks. Rio, Vodafone, Marks and Spencer's, people, Diageo, and so on. Now, we need this FTSE 100 if we are calculating beta. If we are picking the beta from available calculations already from Yahoo. You know, when you go to Yahoo, you can copy the beta from there. Do you all know that beta is already there? Yeah, some of them may not have, then you calculate them. So that's why you need FTSE. So I downloaded that as well. And these are individual companies. Now, these are prices. Notice that it's upside down. The latest price is at the top. And at the bottom is the earliest. So you just need to do reversing, yeah, sorting this, which is again usual thing. Data, and set it by date, and my list has headers, so that's fine.
Are you recording this?
Yeah, it's all recorded. Yeah.
Right now.
Next, I'll just copy this for convenience. You do it the way it's good for you. Actually, I shouldn't have highlighted all of it. $107 data points, isn't it? So we will need that later. Copy. This appears to be weekly, yeah. Yeah, doesn't matter if it's weekly or monthly. You should get the same result.
So what's the preferred time of historical data?
One,
Is 1 year enough for historical?
it's enough as long as you justify it, yeah.
Okay, and they all have to be the same time period?
Frequency, yeah, the same
Okay,
time
so
period.
they all should, so if we're doing a year, they should all be
Yeah.
a year.
Constant time period for all of them.
Okay, so another question that I had, if, for example, we picked 10 companies from the S&P 500, we picked another 10 companies from another, no,
Choose
so
S&P
they all
500.
have to be from the same.
If you're talking about beta, it's usually S&P 500 as a market return.
Okay.
Everyone use market return as well.
So they have to all be from this.
Yeah, choose from the same index. Yeah. No, you can have any others, but then do you have anything to justify that? Yeah, you might want to diversify your portfolio is another thing. Yeah, but there's the question of market return. Which is the best then? Is it Nasdaq? If you choose Nasdaq, some Nasdaq stocks, and you choose Nasdaq. Some of them, yeah. It's just how do you then decide? Yeah, how do you decide which one to use? I mean, do you want to use S&P 500 index as a market return, or do you want to use Nasdaq as a market return? So, I mean, Nasdaq stocks usually, beta of Nasdaq stocks will be relative to the Nasdaq movement, while the beta for S&P stocks are relative to the, yeah. So these different, you get different betas then. But I think it should matter for someone in practicing this thing. But just for consistency, just keep it, and you have 500 different companies basically.
Maybe it's easy. Coming in the morning, early in the morning, or after my training?
Right, so returns are there. Now we will use these returns to estimate the expected return, which is usually, as we said, historical return, yeah? Historical return The reason we use the averages is that we don't have expected return anymore. Yeah, because expected return, something comes in the future. All we can do is just use the past returns as an expected return. So that is average return, yeah? So I'll just say expected return, ER, yeah, ER, oops. It put the trademark thing for some reason. So this is the expected return. And that is usually the average of all this, yeah? So average. So these are my expected returns. So in the future, I expect to earn about 0.2% if I invested in, if I invest in FTSE. And this is also expected return. So past returns are proxies for the expected return. Now I need to find excess returns, or deviations, I should say deviation. It will be easy because you might confuse it with the excess return, like at risk premium. Now each of these minus the average, and I'll just put the dollar sign in front of the number sign here, so that the row is fixed, the rest can vary. It will be easier for me now. Oh. Now it's a trouble here, I don't know up to which point to come, so I need to just have some time frame here. Copy, paste, right, so we still have time to go. So these are deviations from the mean return. These are deviations from the mean return. Next, the difficult part here is the variance and covariance calculation. So this is what we're doing basically for all of them now. So we just calculate the deviation. So if you remember, I'll just draw it to give you intuition. So keep an eye on this. So standard deviation formula was that it's the sum of the deviations, right? I've just calculated here. This whole bunch is just the thing inside this, yeah, xi minus mean. That's what I've just done. If you look at the formula, you see xi b218 minus the x bar. Fixed it with the dollar sign. Yeah, it's these two things. Now I need to square them and then sum them up. Next.
For the covariance.
Yeah. It's a variance covariance matrix comes out then out of that black box. Next. So you need to understand the intuition of what you're doing. That's why I am recording this. I mean, I could give you all these things and jump into just mechanics, but what's the point? Better to understand what you're doing. So next thing is to calculate the sum of the squared deviations now. And I call this x prime and x. X is being the deviations. Because we have large matrix here, it's better to use the matrix algebra. Right. MMULT means matrix multiplication, the formula. MMUL. So I will transpose the returns, well, deviations, and multiplied by themselves itself, basically, all this transposed item. The prime here implies, if you've done the calculus linear algebra class in the past, prime basically says transpose, yeah? You're multiplying matrix by itself, but you need to make sure that there's conformity of the matrix dimensions, yeah? 3 by 2, 2 by 3. So the inner dimension should match. That's what I'm doing here. By transposing, so if I have 3 by 2 matrix, like 3 rows and 2 columns, to calculate or to multiply this matrix by itself, I have to transpose this matrix so that the outer part will become inner dimension becomes the outer dimension. Then I will be able to multiply them, because this should be confirming. Yeah, they should be matching.
Equal.
Yeah, they should be equal. Otherwise, 3 by 2 matrix by 3 by 2 matrix multiplication doesn't work. Yeah, that's from your linear algebra class. So that's exactly what I did here. I am multiplying the matrix by transposing the whole matrix first, so that I get this thing.
Can I make a request?
Yeah.
I know some people already started doing this, and maybe they're nearly finished, but could we get some more days to do it?
More days? Sorry?
Another week
To
finish this and give it to you?
you haven't you think you aren't able to finish in time?
It's not, it's not that, but I feel that when I finish this, I'm gonna give it to you, and
I mean, feel free to email me for feedback.
no,
If you-
I emailed you part of the thing that I did today.
Are you okay? I haven't checked today's one then though. Until 4 I was checking, but nothing up to that. Yeah, feel free to email and see how it goes. So this is, by the way, when it comes to the multiplication, guys, this thing here has to be done with Control Alt Shift. Control Shift Enter, I think. Not Alt, sorry, Control Shift Enter. I'm just pressing Control Shift Enter, but I'm saying Alt as well. So Control Shift Enter, because it's array function apparently. When you use the data arrays and matrix formulas, it has to be Control Shift Enter, not just Enter.
Can you write that right there? Can you make it as a note?
Right, so what to say?
That's fine.
Combination to complete the computation or something like that. Yeah. So it's there. So, however, what's the result here now? This is a huge matrix. Now it becomes a square matrix. I'll have to kind of do the thing. What you call this? The dimensions now change to the number of companies. So we have how many rows here? How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So I have to create or highlight the area which combines 11 columns and 11 rows. It becomes a square matrix, because notice what we had. Sorry. When you have a 3 by 2 matrix multiplied by 3 by 2 matrix transpose, you end up with 3 by 3 matrix, because they cancel out when you multiply them. Yeah. So you have a square matrix. That's similar to this one. We have square matrix, but because the way we multiplied it allows us to create a 11 by 11 matrix now. Yeah, clear? We take the outer, now the inner dimensions disappear after multiplication. Outer dimensions become the new matrix dimensions. So next thing we have to do is now highlight the area that covers 11 columns and 11 rows. So this would be 32, 40, 42. That should be 11.
And another one to the right.
Hmm?
Another one to the right. You're missing one column.
Okay, thank you. Now, once you've done this, you click in there, in here, right in here, and Control Shift Enter. Done. So we've just done the numerator of the formula over there. Next, the denominator. So that becomes the, if we add the denominator, it becomes the variance-covariance matrix. I'll just type covar. This is what investment bankers do in investment banks when they manage portfolios, except that much of it is now done by coding, not in Excel, because it's easier. You have pre-written code algorithm. You just enter the stocks and they will spit out all this. It's like a black box. But if you know the intuition now, when you go to work, you know that what this computer is doing is just in your mind. You understand it. Yeah, you don't treat it as a black box like some unknown stuff. It's not. It's very easy. Right, next thing. So we've just done this part. Now all we need to do is divide by n minus 1. Divide it by n minus 1. Then that will be this divided by n minus 1. So n is the number of observations that we had, the returns. So I will just use count, the function that counts the number of observations of the area that I cover. So I'll just cover this column. I will let it count it. Oh. And minus 1. Now I'm missing the bracket. That's done. Now that's it. Now all I need to do is just recreate this. Done. Down. So it's 45, 55. Yeah. Okay. This would be now covariance matrix. And as a result, what I can do is I'll just copy these guys names, because I'm going to use this. It's my kind of label. These names are labels for me, basically. You will see what I mean in a minute. Control V and right hand. So I'll just do the same thing here. Paste values, transpose, Control V. Done. So this is covariance matrix. All I need is this. Now, because this FTSE is not going to be in my portfolio, all I need is this area. This is the area I will be focusing mostly now. This is the variance-covariance matrix between the shares. This first row and first column should be excluded, in my case. Yeah, because I want to show you how to calculate the betas as well. That's why I included it. Since you don't have them, all you will see will be this yellow area. Only focusing on the shares here. Yeah, only shares. Starting from Rio to Bay and Rio to Bay. Yeah. This unhighlighted area will not be included in your analysis. Yeah. Right. Next. Now we have variance-covariance matrix. We can now calculate the portfolio return and variance for this 10 stocks here. Sorry, 11th is the FTSE. So I'll start with 2 stocks only though, just to follow the guide. Remember the guide? Yeah, we've done this, guys. We are right here. Compute the average returns, done it, and compute variance covariance matrix. So we are 3B at 3B, done it. Now, point 4. Now pick 2 companies from the set. Yeah. Now I need to pick 2 companies. I will just pick the first two. Your choice?
Including the FTSE?
No. I just highlighted this. It's just this will be the first 2 stocks, yeah. So I will type here not doing the name 2 stocks. Only 2 stocks. So which ones are they? Rio and Vodafone. So copy. And if I need this, I have the average on this side, so let me have a look. I could use this, no problem. All I need is now variance covariance matrix apparently in this case. So let me create this now. Portfolio. Weights. Weights. So we need to define that. Portfolio weights, and I highlight this to control copy. Control. Yeah. Right. Next thing. I'll just type here sum, and here I will insert a formula. Sum of whatever appears right under the weights should be appearing right here. So I will impose a restriction on this at some point. You will see that. Next, since we have all of these, why don't we now calculate the standard deviation and the stock, portfolio return for this company? Two companies as a portfolio, right? So let's create this expected return of the portfolio, right? P. Or you could put anything else, standard deviation, and sorry, this is variance, because we will then get the standard deviation. Right. Next, let's do it here. What is the expected return in portfolio? Guys, do you remember the formula for expected return in portfolio analysis? Expected return is basically, okay, let's do intuitive way then, rather than spending time. Let's do. So this done, we've just done and created all the matrices. Now we need to get the expected return of the portfolio, which is weight of the first portfolio if it's two stocks, times the return of the first stock, plus weight of the second times the return of the second. That's it. We just need to use the matrix for that. That's the only difference here. We'll use the matrix algebra. And for that we'll be using matrix multiplication. So far we've been dealing with matrix, yeah? So now this would involve 2 by 1 because two stocks, yeah? So this involves 2 by 1 matrix times 1 by 2 matrix. And if you notice, my average returns are already 2 by 1. Sorry, they are 1 by 2. And the weights here are 1 by 2. Yeah, the weights that would appear right here will be one column but two rows, yeah? The other one is, what's that? One row, two columns, yeah? So I do not have to transpose. What I mean is this. If I go back, you see, this is this part here, this part, this two, is basically, this is the return of the first company, this is the average return of the second company. I just highlight that, comma, and come back, and this should be multiplied by whatever appears right here after the optimization. So change it. I don't actually need, it has the, yeah, so Control, Shift, Enter again. Keep it as it is, it will be value, as it's a normal thing, because we don't know the weights. But let's say if I input 40% in there and 60% in here, I get my average return, yeah, if I enter it. But what I am here trying to do is, I want solver to decide how much weight I should put in Rio and how much weight I should put in Vodafone. Yeah. For now, I will delete them for that reason. So this value is not an error; it's correct. Next, this one is a bit tricky. So here now we need to calculate the variance-covariance matrix here. We multiply the transpose of the variance-covariance by the weights and times it by the variance-covariance matrix for the second time. So MMULT Now this would be, let me have a look. transpose of the variance covariance matrix, and you have to remember that we only have two stocks in this case, guys. Look at this. Look at this. There are two stocks here. That's why we have only got this tiny bit. Rio and Vodafone here. Comma. Not in this one. It should be right here. Comma. Then another matrix multiplication. This is now the multiplication of the weights, these ones, times the variance covariance matrix. So go back and highlight this again. I guess I have all the brackets right. So Control Shift Enter. It's value. Now the standard deviation is the square root of all this.
Can you show again the formula for the variance?
Yeah. I will.
What's the returns in the end? The whole data for the returns.
Oh, the transfer. Do you mean the?
The last one.
These
The
are.
C
These-
300. No.
No, last.
The last
second.
one.
Yeah, where it says sheet 1.
Yes.
These
Is this the
same.
returns?
They are the same. You see,
And that's
these are covariance matrix. The last part of your calculation in the other page.
But it's just the four.
Four of them, yeah.
Four.
Because there are two stocks, isn't it? 2 by 2. It's 4. This is just the weight. These two here. So Control Shift Enter, and next. Okay, leave the next one there. Next, guys, it's the optimization part. So because we want to have the highest return for the, for a given minimum risk, you have to use solver to get this minimized. So what solver does now is, look at the intuition here. It's not difficult. Solver now tries to randomly enter various weights to see what minimizes this but maximizes this. Oops, for some reason the formula didn't work here. So do I have anything wrong here? So 2 here and 2 by 2 there. So it's 2 by 1, and that is 2 by 2. There's a mistake there. That's why it should have appeared. Let me just double check where I collect. So it's C346, D347. C and D done there, and stocks are correctly. So what's not working here? So B18. Yeah. One quick clarification here, guys. This should have been this part here, the transpose part, is the weights, these two weights, and this one, in fact, should be the variance. And this would be the weights. So take a look. I swapped the orders. That's why the matrix didn't conform. The inner products didn't match. Inner dimensions didn't match. Yeah, it should work now. So what solver does now is it randomly enters the different combination of weights, and eventually it chooses the one that gives you the highest return for a given risk. So it keeps calculating until it finds it. So this could be something like 0.001, and this could be something like 0.1 99999, yeah, and it gives you eventually this return, but it basically does this in repeated order. So I'm going to delete this and leave it like this. Now go to data. I don't have the solver now. For some reason it disappeared.
Sometimes you need to add it.
Yeah, I added it actually several times. Remember, I demonstrated here as well how to add it, but it keeps going away, disappearing. So I'll have to go back now again, and where's the options?
Services.
Was it preferences?
I think it's Excel.
Tools, add-ins, yeah, there, that's the one. It's just the Mac version, complicated. But this is the one. Okay, next. Now the objective is to minimize this, so just click min by changing these. And what I want is a restriction. We will add that this number that comes right here, exactly, you can have equal to 1, but smaller or equal to, that's fine. It usually goes to the equal anyway. So okay, now that's done. Click solve and see if what it does. It just with brute force adds different numbers into this two stocks and ends up giving you the best value. So it's done. Keep solve the solution. Okay. Wow, it didn't do anything for some reason. Funny enough. Let me do this. Let me extend this, and I don't know why it did this. Where's the? Yeah, there's nothing. It's actually producing 0. So let me see my data solver. There's nothing wrong with the.
Yeah, because you said it can be smaller than 1, so maybe
Yeah.
it's just making it 0.
Let's
That's
change it.
insane.
Let's do it equal to 1. And then that's why it just puts 0.
Yeah, sometimes I have
So that means your portfolio is not useful at all. It's not efficient. But let's see if it works this way. Yeah, it should have worked actually without a problem. But fair enough. It looks like portfolio doesn't work without. So let me do the standard deviation. ST.
If you have the variance, can't you just do square root and that's it?
Sorry, it's square root, isn't it? Why did I do a standard deviation? Because with one number you cannot get the standard deviation with just one figure, because this doesn't vary. Right, so guys, so solver decided that this combination of weights, this combination of investment gives us the minimum variance for a given return. Now, this is one, yes. You do the next one by adding to this the third stop. The same exercise. Continue doing this. Now, you have a choice here. Either you add 2 stops at a time or 1 stop at a time. If you want to accelerate the process, add 2 stops at a time. So you end up having 15 portfolios, not 29. Yeah? And then draw the standard deviation against your portfolio size. So once you calculate this, you create a new worksheet where you tabulate 2 stock, 3 stock, 2, 4, 6, 30 stock portfolios against standard deviations of each portfolio. So in this case, 2 stock has given us standard deviation of this number. It goes on. Then create a table, graph, where this is your standard deviation, and this is your x, the number.
Okay.
And you should see something like this.
Can you also upload this Excel, the file?
Yeah,
to
I
Upwork? Because the thing is that if you do the video, you need to be watching the.
Yeah, no, I will upload this.
The humidity thing.
Yeah, now that's two stock. The third stock is similar. What changes is that you just add the third stock here, and next you just cover this 3. Yeah, it used to be this 2. Next you could cover the 3. Next you just cover the 4 of them until you come to the 30 stock. This is 10 stock obviously, but that's repetitive. Nothing difficult, is it? And I'll promise you, this is my own experience. When I learned it, when I looked at the traders doing this, it's just they're not doing anything. They are not that smart as they promote themselves to be. They are doing things like what's in the book. All is being done is algorithm. They enter the stock returns, they get the standard deviation, and then they realize that this combination will be best. So we'll just, put the money in these proportions. That's it. That's all that they're doing, portfolio managers. But there's nothing more than that. The only thing is that you have to be strong, because there are cases of markets declining and increasing, and you will be under stress. That's why you get paid well, probably not for the knowledge, but being able to withstand all the pressures from the market movements. Because sometimes you really get stressful. Now, next thing, if those who are calculating betas, that you don't have beta, right? For example, then you just come to the part where you calculate the returns. This is this one, yeah? This one here, returns. These are returns. Now, the beta for the first component. So just let's create this, guys. Let's create betas. And let's bring the guy here, this guy. All I need is now a statistical input here. That's it. That's basically slope function. Slope. Now I need to choose my y, I need to choose my x. And all I will do here is the standard simple regression. This powerful function, what it does is just estimates this regression. This is what we're looking at. The slope gives us this beta, which is this is the stock return, this is the market return, and this measures the sensitivity of stock to the market return, this beta. Yeah, that's the intuition behind this function. So, slope. So I just need to highlight the y. And remember, I had the y in the first case, yeah, first row. So I'll just highlight that. Comma. And highlight the x. You can then compare it the one that you copied from the website. That's the beta.
Did you have to use as x FTSE?
Yeah, I used the FTSE, didn't I?
No, you did it the other way around.
What did I do?
Which
You
is
said
why
y.
Oh, let me go back. Let me go back and see. So B
B
was
is FTSE.
FTSE, yes,
So why you have FTSE?
because that's a market
No,
index.
I mean, you're using y's.
Thank you. Thank you. I described one thing and did one thing. Many thanks.
Forest is
Sorry, guys.
These are the betas.
The brain malfunctioned badly. That's the beta. Sorry, I was surprised to see a very low
first is
beta.
the stock and then is the index.
Yes.
Yeah. And now, guys, once you do that, all you should do is highlight this, F4. Where is F4? Dollar sign, yeah. And just do this, guys. So all the betas are there. You don't have to calculate anything. Just first one, the rest will be done. Because you see, this is the next stock, isn't it? Yeah.
What's Bay? The last one?
Bay? I don't remember. BA Systems or some other. It's BAT, Arbos. Because I downloaded a long time ago. You remember? This is
2005.
from 2005. So probably I downloaded the one when I did my master's. Something. It's an old one. But I saved everything that I had, so I'm using them now. I should have downloaded the recent one. Anyway. Waterfall looks like has a very small beta. Now, to calculate the portfolio beta is now, you multiply weights, these weights. Yeah. Now, the portfolio, two-stock portfolio, yeah? Two-stock portfolio is basically these betas times
The weight.
the weights. So it's again matrix multiplication, isn't it? MMULT. Oops, my double click is working badly. So is basically now we have to have row by column multiplication. 2 by 1, 1 by 2. Sorry, it's the opposite I should have really. So we will do so this times this, and go back, Control Shift Enter.
No,
So that again it didn't
because you did it with betas.
why do I choose the beta twice?
No,
So
because when you came back, you
did it choose?
Yeah.
Sorry, thank you.
Two stocks.
Two stocks. It's this one, isn't it?
Yeah.
So I have to be very careful now and then come back. Yeah, done it without me trying to do anything. So anyway, Control Shift Enter. That's the guys. This is the portfolio beta for two stocks. Then three stocks, four stocks.
Sorry,
Just keep.
the formula was the two betas times the weights,
Yeah.
right?
So it's this one here. Beta of portfolio is beta of the first stock times the weight plus beta of the second stock times the weight.
So you also want us to calculate the portfolio beta for all the portfolios we have.
Yeah. Now look.
We do it for one, we can do it for one.
No, look. I want you to learn what the theory says. Look, I want you to realize what I want you to just remember this. I'm not doing this for, taking your time. I want you to tell me if this is beta, isn't it? This is the systematic risk.
Yeah.
But this part disappears. I want you to see if really is theory is working here. In the end, we have 30 stock beta. You need to tell me if, as you increase the stocks, beta goes down or not. Theory says it doesn't.
So basically, the whole point of this is just to
Prove the
verify
theory wrong.
No, for you to understand what you're doing. All this is
verify the theory.
exactly. You can think of that way as well. Now, the standard deviations that we had there will tell you whether this function is correct. Or verify that this goes like this, exponential declines and flat. Now the betas tell you as this guy goes increasing to 30 stocks, will the beta remain the same? Like will we get, if I do the 3 stock beta, portfolio beta, will the portfolio beta remain as 1, 1, 1, 1, or the same number? Okay, there will be some variation, ignore it. But I want you to understand this. I mean, this is the gist of doing finance, isn't it? This is the aim of this module. If you look at the aim, it says to understand modern portfolio theory and applications. I mean, this exam is not it's a theory. You can memorize it and come back and say, okay, I got A. But what's the point? When you go to work somewhere else, you need to be confident. Huh? This whole thing should be valuable to you, not just a paper A or B or C. It should be something that you enjoy. Quick marks kill your chances of passing the interview, first interview. But when you do intuitive and reasonable thinking, that's what guarantees you a job. Yeah, obviously marks also guarantee, but if you understand it, you certainly get the high marks. Any questions on this? So all of it is done. The last part is creating this efficient frontier, which I will leave to the later discussion, because you just finish this in the next.
Do a video for that, right?
Of course, with you in the room, present. If I just upload the video, I don't know how it goes.
Can you also upload the file?
This file will go, yeah.
Yeah, because
You can check the formulas, for example. I would say, if use this as a template. Yeah, use this as a template. All you need to do here is drag, and then you need to obviously need to learn how to drag it, because you might mess up if you drag and without understanding. So study it properly, drag. You're done within an hour, and then all you need to do is just copy and paste 30 stocks here. It's all dragging. Why you? It's the first time. That's
we
why.
have to do 30 pages, and for every stock we need to use solver. You don't take an
Ah,
hour.
that's
This can
fine.
take you like 4 hours.
No, it won't take you
Because
for.
you have 10 stocks there, and look at the amount of rows you need.
Always about dragging, isn't it? Dragging. Is there anything complicated? No. So I'm gonna save this and upload this. Oh, actually save it. I just need to push the button. Now, first thing is I haven't received much of,
The thing is, it's
many emails that I expected from you. Only a few.
But the things that I did
It's just you need to email me if you don't understand anything, rather than going and trying to do it and taking your time and getting frustrated. Email me. I'll upload it on Blackboard. Next week we start with share valuation, then bond valuation, and then futures.